Now that you've tried an introduction to using flow modeling in Solidworks with the previous video, and it was pretty simple, and I didn't even go into looking much at the results, let's go in and really try and figure out how to use this tool. Now, one of the things that's really important to know about fluid modeling is that it's not easy. And you can make a model and run a simulation and get a really beautiful looking set of colored graphs. But the real test is, can you validate that? Can you actually get a result that's numerically similar to what some kind of calibrated flow would show you? Well, that's what we're going to try to do today. Now, the example that I'm going to use is one that's very well studied, and it's hard. And it may seem utterly simple to you in what we would expect to see, and that would be a simple airfoil. We're going to model a simple, linear, boring wing in a crossflow. And let's see what we can get out of that. And we'll compare it to real accurate results of lift and drag coefficients. So we'll start with just looking at an airfoil and lift and drag coefficients, and then we'll move on from there of importing that into Solidworks and then creating the simulation and running it. So let's get started. Here I am looking at a website called airfoiltools.com. It's an open website that has all of the NACA standard airfoil sections tabulated. And what's great about this is that we can pick a generic or a specific airfoil section, and we can get the data for it in terms of the profile of the airfoil, and we can get the performance coefficients of lift and drag coefficients. So we can use this data to both drive a model that we can then run in the simulation, and we can look at the results data and see if our results compare reasonably with this. So just to get started, what I want to do is I'm going to pick one of these. I'm going to just randomly pick an NACA 4-digit airfoil. And you can put in here any digit numbers, and I'm not going to get into explaining what the NACA airfoil series means. That's for another course. But we're just going to put in a 0010 airfoil section. And the data is available for that. Now, it's a symmetrical section, so it doesn't have any of what's called camber. It's just got a straight line, center line. So it should be very familiar to anybody who's looked at an airplane wing. Now, I can take the data, which is presented right here in just a simple XY curve, and I can just highlight it, Control C, or copy it, and minimizing that, going into Solidworks. Now here we are in just a Solidworks part, and I'm going to show you how to insert a curve in here. Now we're going to insert from the Insert menu under Curve. We're going to do a curve using XYZ points. Now you'll see that there's a window comes up like this, and you can browse and upload a file. Now what I've done before this video is I took that data that I just cut and pasted, and I put it in an Excel spreadsheet where I've got X, Y, and Z. Now, because of SolidWorks' necessity to have it a three-dimensional curve for the input, I had to add 0 for Z. That's fine. And now I've got these three parameters. And once you've done that in Excel, what SolidWorks wants from you is a plain flat text file. So if you go up to Export, you can change the file type, and export it as a simple tab delimited file. It won't read that though. It wants to have a this PRN format, just a straight print format. And if you go save as, it'll be a text file with spaces. And if I do save as there, and just simply make sure you change the file name type to text. And the easiest one, the one that I was able to make work with no problem at all, is an MS-DOS format of text. There's a blast from the past. And if you save that wherever you're working, then I'm just going to cancel because I've already done that. I can go and browse and look for a text file, and you'll see that I've saved that NACA text file. I open it, there's all the numbers. Now, unfortunately, I have all of my dimensions in this set up in millimeters, but that's all right. There, and now we've imported it into this curve. It's only a millimeter long though, and it has another little feature problem that I'm going to need to fix, and that is it's a starting and an ending curve. So I want to extrude this, but I can't extrude it while it's an open curve. So I'm going to insert a sketch. And I'm selecting the plane on which this curve is. I'll convert this entity. So there, that's now a sketch in my world. And I want to bring that and that. Oh. I guess it won't let me extend. So I'll just add a new line segment from there to there, tangent, and then trim. There. So now I've got a closed body, which will be perfect. Now, even though it's only a millimeter long, I brought it in with the units undefined, and then because my units are set to millimeters by default, I'd like to scale it. Before I scale it, it's hard to scale a sketch like this. The easiest way for me to scale it, and maybe you've got a better approach, is after extruding it. So I'm going to extrude it. I'll make it, I know it's 1 millimeter long, I'll make it oh, well, 10 millimeters would be fine. Like that. And then I'll use a feature scale, and I'm going to scale it. It's in millimeters. I want it to be I'm going to make this as a hydrofoil, so I want it to be 10 centimeters long, 0.1 meters. So I'm going to scale it by 100. And I'll scale not about the centroid, I'll scale about the origin. There. Now if I check this by measuring it, evaluate, measure that point to that point, it's 99 millimeters, 99.91 millimeters. Basically, that's the better part of 100 millimeters or 0.1 meters. And that's what I want. And likewise, the length of it is from here to here. And that's, what was that? I don't know about you, but I find the Solidworks measure tool in Evaluate is kind of a pain. There. Yeah, so it's 1 meter in width. And that's what I'm looking for. So I've got this airfoil now, and it's the cross section of the NACA series that I chose. And I'm just going to save that, and I'll call it oops, I guess it was 0010. There. So I've got this wing. So I'm ready to go, and kind of a horrible viewing angle right there. That one's no better. There. So there we have this long skinny wing. The reason I'm making it a long skinny wing is because the basic wing models are assumed to be two-dimensional, and the air tunnel testing, wind tunnel testing that was done to get the data that we used to compare with was done on long slender wings. So the theory is for long slender wings, and the test specimens that we compare with for drag and lift coefficients were long slender wings. So our CAD model should be reasonably close to that. Not a very elegant and exciting CAD model, but let's just see how close we can get this result to the real world known result. There, we've added the two-dimensional shape of the NACA 0010 airfoil into Solidworks, and we've created a long, slender airfoil as a solid. In the next video, we'll move on from there and do some flow simulation.